Hi, this is going to be the first video of Unit 5, which is on ratios and equivalent fractions. Um, there are a few skills that you should already know how to do from previous grades. Simplifying fractions is a big one. And then knowing a little bit more about what it means to be equal for two numbers. I'm not going to dive too much into that, but that's just some basic things that you really do need to have good concentration on, because I'm not going to focus too much on reducing fractions because you should know how to do that already. A ratio, it's a comparison of two quantities. Well, it's a way of comparing things from one amount of items to another amount of items. So I've put some examples, some real world ratios, like cooking. For one cake, you have to have 2 eggs and 3 cups of flour or something. So in cooking, that ratios are used for ingredients. Models, whenever you build, an architect builds a model of the city, or if you're making a model of the house that you're going to build when you're older, or you're planning out a model house with an architect, you have to build a model to scale. Well, you use ratios to go from the real world to the diorama that the guy might make. Same thing goes with maps. When you go on Google Maps, well, the Earth isn't as big as your computer screen. It's far bigger, but because of ratios, it's sized it down. Same thing goes with construction and models. So those are some really, really real world things that you have to be able to understand ratios to go from a diagram to the real thing, or going from a real thing to the diagram. Because sometimes you have to go from the real to building a model of it. So those are some very, very fundamental things. Ratio. Let's talk about ratio. Ratio might seem a little familiar. If you remember, I always ask when I teach rationals, what are the first 4 letters of rational? Ratio. And we say a rational number is any number that can be written as a fraction. So fractions and ratios go hand in hand because they're basically the same thing. But the way they're used is very hands-on with ratios. It's very very concrete and not very abstract. So here we go. Example number 1. You might be asked a question to write the ratios in simplest form. So try and think about what that means. I don't want to do the fractions one yet, because the fractions is the way you'll probably end up doing it most of the time. We'll go with triples. I will draw in red girls, and I will use purple for boys. Okay, so there are 18 girls to 12 boys. So say this is a classroom and you got 18 girls and you got 12 boys. Okay, what it means to simplify is, how can I make as many groups as possible that have the same number of girls and the same number of boys? That's what they mean to simplify. Now, another thing is also this: you cannot saw a girl in half. I know, boys, I'm really bummed about that too. But we're not magicians, so we're not allowed to do that. So here we go. I'm going to draw 18 girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here, let me zoom in a little bit for you guys. Better view. Let's see, 12, 15, 18 girls. So I've got 18 girls, and you might be thinking, hey, Mr. V, how come you did that? Well, I'm already looking ahead, and I'm thinking about, I know, I've got the fractions method, but I'm thinking in my head, how can I put them in the same number of groups as boys? So I'm thinking of a number that I can divide both of them by to make the same thing. To make the same amount of boys and girls for every group, because we want to be fair. Well, I got 1, 2, 3, 4, 5, 6. 18 divided by 6 is 3. That's why there's 3 in every group. Can I divide 12 by 6? I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. And hey, look, I've actually, and you might need to play if you're drawing a little bit, and that's fine, you gotta play with it. But look, I've got 5 people in every group, but we're not gonna say, oh, there's 5 people in every group. What we say is, there are 3 girls to 2 boys. Two boys. So that would be my answer, because in every group there are 3 girls to 2 boys. That's my ratio when I've simplified this down. Huzzah! But so that's how I would do it with triples. Now fractions. Let's zoom this out a little bit. With fractions, it's kind of basically the same thing, but not really. So what you do is you take 18 girls, 12 boys, and it's actually just like fractions. If I was going to simplify, I have to think of a number that I can divide both sides by to lower the number by, and I have to do it equally. So I'm thinking of a number I can divide by 18 and 12 by. So I can divide, both of them are even, so I can divide both of them by 3. Or sorry, they're both even, so I can divide them both by 2. 18 divided by 2 is 9 girls to 6 boys. And that's totally true. There are 9 girls to 6 boys. Well, if I double both of those, that's the class still. And well, 9 and 6, I know I can divide 9 and 6 both by 3. So we got 3 girls, 2, let's see, 6 and 3, 2 boys. Hey look, that's the same thing I have right here, 3 girls to 2 boys. So it's just like a fraction. Whatever I do on the one side, I have to do on the other. Sometimes this is written as a fraction flat out, and you just simplify it. Sometimes it's written like this. So it depends on how you see it. So that's our first example. Let's do another example. Let's say I have 10 mice to 5 snakes, because I have to feed each. Well, let's think about that. I have 10 mice to 5 snakes, so I'm gonna draw a little key again. So let's say this is a mouse, and this is a snake. And just because I'm like that, these are mice. Oh, so cute. Yeah, they're gonna get fed to snakes. My snakes are hungry. Alright, well, I know I've got 5 snakes, and if you think about it, I know I'm gonna have to divide. Well, the only number I can divide 5 by is 1, which doesn't do anything, and 5. So I know I'm gonna have 5 snakes. So if I've got 5 snakes, I need to think, well, if everyone gets 1 mouse, because I'm trying to be fair for every snake. Everyone gets 1 mouse, everyone's probably going to get 2 mice. Because 10 divided by 2 is, or 10 divided by 5 is 2. And hey look, if I've done a fair thing, I have 2 mice for every snake. So I'm going to write that down. 2 mice, 2, 1 snake. But I'm hoping you're starting to see, like, it's exactly like a fraction. All I'm doing, and I'll do this one like they do this in the book. I prefer the other way, which I'll probably do more often in class, but I'm all for this way too, if you understand it. If I write this as a fraction, because it's a ratio, I have 10 mice and 5 snakes. Well, I can divide this by 5, and whatever I do on the top, I have to do on the bottom, just like a fraction. And that means I have 2 mice for every 1 snake. Yeah, pardon the handwriting. Well, I can't leave my answer like that because that doesn't really make sense to me. I really do want you to write a fraction or a sentence. 2 mice to 1 snake. And that's actually a pretty big deal. Like writing sentences for unit 5 and 6, I'm actually like crazy about. So that's the main thing. There is one also last little vocab word that we need to talk about, and that is equivalent ratios. That is having a ratios, like any number of ratios. It doesn't have to just be 1. It could be, or 2 of them. It could be more than 2. But when I simplify them completely, they have to be equal. So, like if I'm looking at the ratios in like example number 2, just flat out ask, are the ratios equivalent? Well, are they equivalent? I don't know. So what I do is I'm going to draw like a balance. I'm going to draw like a little line to separate these two. And I'm going to say, well, 12 over 14. I don't care what's happening over here. That fraction doesn't matter because I have to simplify them both before I can make a determination. 12 over 14. I can divide the top and bottom by 2. I'm allowed to divide top and bottom by 2. Well, 12, because it's a fraction. I'm simplifying it. 12 divided by 2 is 6. And 14 divided by 2 is 7. So what I want is for this to be equivalent to this fraction, it better simplified as 6 over 7. Well, let's check. I can divide top and bottom by 3. And this would be equal to, well, 15 divided by 3 is 5. And 21 divided by 3 is 7. So the question now is this. 6 over 7 and 5 over 7. I can't simplify them any further. They're completely simplified. Are they equal? The bottoms are, the denominators are equal, but the numerators, they're not equal. So this does not work. They are not equal. So I'm not going to use those two numbers though. I'm going to go back to the beginning and I'm going to say 12 14ths and 15 21st are not equivalent. And if they were equivalent, I would say they are equivalent. Like that's literally, that example number 2 is how you do all those fraction types. That's it for this video. It's a lot of fraction stuff and just, it's basically using what you know about fractions in a different way. Have a great day.